Okay, we'll see that next question, number 4 in vectors. This is my second video of vectors. Please subscribe and press the bell symbol, and you'll receive my all continuous videos in either combined maths. So we worked already in the previous video, big 3 questions. I explained full clear notes and full workouts of that problems. Continuously we'll see the 4th question. So write this question. Vector A and vector B, vector A and vector B are two non-zero, non-parallel vectors. Are two non-zero, non-parallel vectors. Full stop. Position vectors of the points. Position vectors of the points. Position vectors of the points P, Q and R. P, Q and R are 2A plus B, 2 vector A plus vector B, comma, vector A minus vector B, and 3 vector A minus alpha times vector B. 3 vector A minus alpha times vector B, respectively. If the points P, Q and R, if the points P, Q and R are collinear, find the value of alpha. Find the value of alpha. So it's the question simple, it's like a structure type. So I'm giving every problem so ideas how to work, what the knowledge we require for such a questions, the concept of the basic vectors we'll use here. So they said A and B are no zero vectors, they are not parallel. Non-zero, non-parallel. If you work many vectors, the grade 12 chapter, the word form comes like these non-zero, non-parallel vectors. Okay, I'll show by a diagram. I take the origin as O, any point is O, and 3 points they shown P, here I say P here, P, and I say here Q, P, Q, O, here R, I say this is Q, this is Q here, here R, so you can mark where the O is the origin, the reference point related to O, we define these unit position vectors. P, they said 2A plus vector B. The position vector of P is reference to the point O, 2A plus B. Q is vector A minus vector B. And finally the R, 3 vector A minus alpha times vector B. So by a diagram you can draw this and mark these details. So now they said the points P, Q, R are collinear. That means along a straight line. Along a straight line. So if I draw this it's not a straight line, no matter that one. So especially better you not show a straight line. This is straight like this. And P somewhere here, Q somewhere here, R here. Then find the alpha. So here what the idea of answering such a collinear problems or along a straight line. The vectors or points are given along a straight line, lie along a straight line. How to answer such a problems using vectors. So in this case, so in coordinate geometry we call along a straight line mean their gradients are equal, they are parallel along a straight line. The gradients are equal. But here they say A and B are non-parallel, non-zero vectors. So here you take a relation between PQ and PR. PQ and PR. PQ and PR or QR and the largest PR. Take a relation, how many times PR is some lambda times of the PQ. PR is lambda times of the PQ. And like that we modify in form of a vector addition of triangle, and we can use some knowledge to calculate the alpha value, right? So here I take, let PQ, vector PQ equal to lambda times PR. Lambda times PR. PQ equal lambda times PR. Or you take QR equal lambda times PR, no matter whatever the idea. So it's better don't take the PQ separately and QR separately. The best work, take the large and the inner side small part. So now we write PQ. You know what the PQ? What is PQ? So if I take this triangle, what is PQ in triangle? In triangle OPQ, in triangle OPQ, what is vector addition of triangles? PQ vector equal PO plus OQ, no? PO vector plus OQ vector. PO plus OQ vector. So what is PO? OP is 2A plus B. OP is 2A plus B. Now PO means minus, arrow reversed, negative sign. So minus into 2A plus B. Plus, what is OQ? A minus B, right? A minus B. A minus B. So then we can simplify them. So if you learn this unit position vector additions involving this type, PQ vector is Q minus P. PQ vector means Q minus P. Q minus P. So I show therefore PQ is A minus B minus 2A plus B vector PQ equal lambda into PR. Same method you can draw a big triangle OPR, find the triangle additions of vectors. Otherwise we call short form. What is PR mean? Reference to R minus P. R minus P. PR means R minus P. AB means B minus A. So what is R minus P? R vector 3 vector A minus alpha vector B. This is R. PR means R minus P. That one 2A plus vector B. Okay, such a collinear pattern, you take this, let PQ equal lambda times PR. Now simplify. Simplify is how many is 1A minus 2A minus vector A minus 2 vector B minus 2 vector B. So here lambda into how many is 3A minus 2A 1 vector A 1 vector A, and how the B values minus alpha B minus B. You can take the minus out, then alpha plus 1 is it? Is okay, minus alpha B minus B. Okay, right. Now they say vector A and vector B are non-zero, non-parallel vectors. Such a case, in vector equation like this, both side coefficients are equal. Coefficients are equal. So if we equate the coefficient of the vector A both side, also vector B both side, you can get the answer for lambda. Once you know lambda, you can get the alpha or any what they ask, right? So right below, given that vector A and vector B given that vector A and vector B are non-zero, non-parallel vectors. Non-zero, non-parallel vectors. Therefore, by equating the coefficients, so I take like this, I equate the coefficient of A. That be in front of number value, Newman value of in front of A. We have -1 equal lambda times vector A. Therefore lambda, there's no any vector A. So I mentioned the lambda value, so I found that lambda equal -1. Same method, equate the vector B both side. So here -2 equal lambda times this, therefore minus lambda into alpha plus 1. Second equation. So first equate the vector A both side, coefficient of the vector A, and second part vector B both side equate. The question is find the alpha value. So now divide. Substitute for lambda here or divide. So if I divide 2 divide by 1, 2 divide by 1, alpha plus 1, but there's a minus, and 2. So simplify alpha equal what? -3. Alpha equal -3. So simple question, but the idea. Sometimes we study very big, large problems. Small parts for simple cases, we forgot the basic ideas. The best chance once again to revise this type of collinear problem. Also non-zero, non-parallel mean what? It's the method how to apply that, such a note of vectors. So you pause this video and recollect and find your own knowledge and tally with me by the answer and check accuracy of this work and my explanations. Okay, then we'll see another question number 5. Problem number 5, the same as you can work, you try this problem, question number 5. So write this question. Vector A and vector B, are two non-zero, non-parallel vectors. Position vectors of the points A, B and C. The position vectors of A, B and C are alpha vector A plus vector B, alpha vector A plus vector B, 2 vector A plus 3 vector B, 2 vector A plus 3 vector B, 4 vector A minus 3 vector beta. So that's not beta, but 4 vector A minus B vector B. 4 vector A minus beta vector B. Beta vector B. The position vectors of the 3 points are given like this. Right, where alpha and beta are scalars. That means constant numbers. Alpha and beta are scalars. Write this question. If the points A, B and C, the points A, B and C are collinear, find the relation between alpha and beta. Find the relation between alpha and beta. Find the relation between alpha and beta. So I hope you can work this. If you refer my that fourth question, follow that order the same. Here only alpha, value on alpha there. Here the connection, you can calculate the alpha value separately here, beta value separately here. Then you need two equations now, but only one you can collect it by writing the triangle addition of a vectors. So you can get this relation in terms of alpha equal to how many betas or something like that. You can try, right? Okay, we'll see this question, problem 6. Right, next question. In the usual notations, let 3 vector I and 2 vector I plus 3j, 2 vector I plus 3j, 3 vector j, be the position vectors of 2 points A and B, respectively, with relative to origin O, let C be the point on the straight line. OB such that OCA angle equal to pi by 2. OCA angle equal to pi by 2, or 90 degrees. Find vector OC in terms of I and j. Find vector OC in terms of I and j. This we can work now. It's like a structure type problem. The first video I worked I think 3 very nice questions in the first video. There I shown how to use the dot product, scalar product, how to apply that in the questions. So also I think this you need the angle. The angle is provided, you need this dot product idea. So please subscribe this also. We have the video number 1, and if you subscribe, you'll continuously release my attractive combined math solutions, questions of any revision type problem. I hope to release many this kind of questions, discussions through this YouTube channel. So how this? So if I show this indicate by a diagram form, the O, everything, the position vectors are usually denoted by the respect to origin or any reference point. Let's say question starts usual notation. What do you mean usual notation here? Vector I, what is vector I? Unit vector along the x-axis, and vector j, unit vector along the y-axis. So here they said 3 points A, B and C. First they set the point A and B. we mark somewhere here A, respect to origin they say unit vector 3i is 3i, and B, that is 2i plus 3j, 2i plus 3j, vector B. Usual notations that A, B are given. And they say there's a point C. There's a point C where the C lie on the straight line OB. C lie on point OB. So therefore, you can mark somewhere here. C. C lie on the straight line OB, and OCA angle, where OCA, this is 90 degrees. OCA angle 90 degrees. Then find the OC vector. They ask calculate the OC vector. So we use this vector idea. Especially you can use the previous question, the problem, fourth problem, the collinear idea. So here indirectly they said OBC a straight line, collinear points. So they also we have some idea of the vector knowledge. So pause the video and try yourself. You can try your knowledge of the vectors, how to get this answer. Then see with me my solution, my explanation. So first I find the OC vector in the pattern of a linear form vectors, because collinear idea. Therefore I said here, let OC equal, so straight line, so I take OC equal some lambda times OB. Lambda times OB, because B is given, OB, B vector is given, question vector of the B is given. Therefore, OC equal lambda into what is OB, 2 vector I plus 3j. That's what where lambda is a constant or scalar. Lambda is a scalar, right? So in this case, we have to calculate the lambda value. What the value of the lambda? Then you know the OC vector in terms of I and j. So OC become a times the ratio of this 2i plus 3j. How many times of that? So lambda be a number. So main part hereafter, calculate the lambda value. Now is the collinear vector knowledge. Now we come to the right angle. These two vectors are right angle, orthogonal, perpendicular to each other. So what happened? Two vectors are right angle. If you product these two, it becomes cos 90. Cos 90 is 0. Cos 90 is 0. So vector CO and CA. Vector CO and CA. If you product it, scalar product, answer is 0. Therefore, we have another equation on that case. Here the OC equal to what? And try to find the dot product hereafter. So now, you know OC, therefore you know CO. Now we find the CA. CA vector CA. Take this vector addition in triangle OAC. In triangle OAC, what is CA vector? Triangle addition of vectors CA. CA is CO plus OA. CO plus OA. CO plus OA. CO plus OA. What is CO? Actually, OC is lambda times this. Therefore, CO means minus, reverse, arrow, negative, minus. So, minus lambda, 2 vector I plus 3 vector j. Plus, what is OA? 3i. OA is 3i. OA is 3i. I can further simplify this. I take the I component separately. Minus 2 lambda plus 3 into I. minus 2 lambda plus 3 into I minus 3 lambda j, vector j, right? This is CA. Now we'll say about the angle is given. So next you can write this. Given that OCA angle equal pi by 2. Given that OCA angle 90 degrees or pi by 2. Therefore, vector CEO and vector CA dot product it equal to what? The first video I start from the beginning, that scalar product. What is dot product? Mod of vector CEO into mod of vector CA into cos 90, that is 0, therefore 0. So now we are available what is CEO, what is CA, and connect the answer. So CEO, so here CEO answer is minus lambda into 2i plus 3j. This is CEO into CA, one CA minus 2 lambda plus 3 into I minus 3 lambda into j equal to 0. So in another part here, as the question start, the usual notation I, J, K. Here no K, I and J only. They are unit vectors along the respective axis, x-axis and y-axis. So what is I dot I? If you learn this I dot I, dot product of I dot I, same unit vector product, but the answer mod I, again mod I, cos 90, so cos naught, I, both vectors are same along a straight line, therefore cos naught. You know I is a unit vector, therefore its modulus is 1. So 1 into 1, cos naught is 1, therefore I dot I is 1. In the vector problem, usual notation, I dot I is 1, j dot j is 1, also k dot k is 1. Okay, therefore, that idea you need to multiple this. So you can neglect this minus, not a problem here. Multiple this bracket, this in this. So here 2, or if I take with the negative, no matter. This one multiple with this I dot I is 1. Therefore minus 2 lambda into minus 2 lambda plus 3. When you multiple this product, this multiple this to bracket or product it, this into this I dot I 1. So minus okay, minus 2 lambda into this I dot I 1. Okay, see minus plus j 3 lambda into 3 lambda equal to 0. J dot j is 1, right? Here minus 3 lambda, here also minus, therefore minus plus j dot j 1. So here you can find the lambda is a scalar, but lambda not 0. If lambda 0 comes, that's no idea of the position vector of C. So lambda not 0. So if I multiple this bracket, 4 lambda square minus 6 lambda plus 9 lambda square equal to 0. So 13 lambda square equal to 6 lambda. Therefore, you cut by lambda not 0. Therefore, divide by lambda becomes 6 over 13, is it? Lambda equals 6 over 13. Lambda equals 6 over 13. So, what is the question? Find the position vector of C respect to the origin O. Now we mentioned is CO, OC equal lambda into that. OC equal vector OC equal lambda into 2 vector I plus 3 vector j. OC equal 2 vector I plus 3 vector j. Therefore, lambda 6 over 13 multiple 12 over 13 I plus 12, 6, 18. 18 over 13 into j is the vector OC. That's the answer for that problem. So nice question for structure type problem. So here we use especially the collinear idea and the dot product application, scalar product. Okay, we'll work another question. Mine that is 7th problem. 7th question. So write down this question. ABCD is a quadrilateral. ABCD is a quadrilateral where vector AB equal vector A, comma, vector BC equal vector B, comma, vector CD equal vector C and DA vector D. ABCD is a quadrilateral, four-side polygon closed figure where AB is vector A, BC is vector B, CD is vector C, DA is vector D. We'll work with this big question, the essay type problem, one by one. So write the first part. First part, show that vector A plus vector B plus vector C plus vector D equal to 0 or 0 vector. First part, show that A plus B plus C plus D equals 0. So it's better we complete this and I read the second part because the big question, large part. So first we complete this one. So draw is the vector geometrical part, this one. So draw a sketch of this quadrilateral and complete. Draw rough diagram quadrilateral like this. Say B, C, D, A, B, C, D. So they said AB equal vector A, BC equal vector B, CD equal vector C, and DA equal vector D. So that's a true thing that especially first time the grade 12 when you start the vectors, beginning of the vector we say any vector polygons, triangle additions can be transformed or extend to the triangle, quadrilateral, pentagon, hexagon like that. In order if you add all the vector, answer is 0. Answer is 0 vector. Okay, anyhow, once again, we'll prove this by geometrical or vector additions. So what the idea? So if I join this, let's take this triangle ABC. Take the triangle ABC. AB plus BC equal AC. In triangle ABC, in triangle ABC, AC equal what? AB plus BC. AB plus BC, that is what? A plus B. Let's say first AC equal that. Again, see the AC answer. Take the lower this triangle, the below this triangle, ACD triangle. Again, AC is what? AD plus DC. AD plus DC. Right? In triangle ACT, in triangle ACT, vector AC equal AT plus DC. AD plus DC. So what is that? AD is what? This is D. DA is vector D. So AD is minus vector D. So this is minus vector D. What is DC? This is vector C. Other side minus vector C. That's all. So now both are same. Both vectors are same. Belongs to AC vector. Connect the both. Equate the both. We have the answer. So 1, 2. 1, 2 gives that AC for A plus B equal to what? Minus D minus C. Take all this side. Then in order A plus B plus C plus D equal to 0. A simple answer. A simple form. The first part of this question, A, B, C, D, summation of the A plus B plus C, show that is 0. Right, second part of this question. Second part, if vector A perpendicular to vector B, if vector A perpendicular to vector B and vector C perpendicular to vector D and vector C perpendicular to vector D, if vector A perpendicular to vector B and vector C perpendicular to vector D, show by using the scalar product, show that mod of vector A square plus mod of vector B square equal to mod of C square plus mod of D square vectors. It's a nice part, nice question. Using the method, follow that order, using the scalar product. By using the scalar product, you can connect it. So the further addition, this part is over, okay? So additionally they said, now vector A and vector B, right angle 90 degrees here, 90 degrees. And vector C and vector D also here, 90 degrees, both are right angle. Then you know the idea of the dot product. If two vectors are perpendicular to each other or right angle to each other, their scalar product is 0. A dot B 0 and C dot D also 0, right? And it's a continuous big question. We have this first part answer. I said that is R. I complete the first part answer. Say R. The answer is we so says that R equation R result. Okay, now we show that idea of the orthogonal or perpendicular to each other. So vector A perpendicular to vector B, given vector A and B are to each other right angle. Therefore A dot B equal to 0 because mod A, mod B cos 90 is 0. Also write the next one. Vector C dot D equal to 0. C dot D is 0. Therefore that is mod C C dot 0. That's enough. C dot 90 degree. C mod C show the same method. C and D 90. Therefore C dot D 0. So in the future showing that method, that answer, you have to implement these ideas. Okay. Now what? How to get this mod A square? When the mod A square comes, A dot A is mod A square, B dot B is mod B square, C dot D, C mod C square, D dot Z, D multiple the both same vector, D dot D mod D cos naught, they have become mod D square. So therefore to get this answer, you need this result. First part is important to complete this successfully, correct this solution, this math answer, right? Therefore see this, from R I can take A plus vector B equal to what? Take that side, minus into C plus D. Minus into C plus D. That A plus B equal to minus into C plus D. Now for collect this answer, we need the mod A square, mod B square, mod C square, mod D square. You have to product it, dot product, then only it's possible. So therefore, you multiply this again itself, product it, itself product it. Therefore, A plus B dot, again say A plus B. Here also minus become positive plus. So this is C plus D multiple C plus D. That means same vector product itself. Then only we have chance for a modulus of the same. Now multiply the bracket. A dot A dot B, again A dot B, now B dot A means therefore 2 times, right? 2 times A dot B plus B dot B mod B square. Let's say first B dot B, right? B dot B. The other side same method. The other side. C dot C mod C square. I write C dot C. C dot D dot C 2 times. So what is that? What is A dot A? Mod A cos naught. Mod A square of that. Therefore, mod A square plus, you know A dot B is 0 because they are orthogonal to each other, right angle vectors. They are 0. Mod B square. The same method, mod C square plus 0 plus mod D square. Therefore, you can take the answer, this answer available. Okay, this answer available. Mod A square plus mod B square plus C square plus D square. I mentioned equation number 1 earlier, adding triangle addition. Also number 2, I say this number 3. So pause the video and check it whether it's correct accuracy my explanations of this problem. How to work using the scalar product of this. Oh, it's the second part of this question, big problem essay type question. We have another part. Part number 3. Write this third part. If the angles between vector B and vector C, the angles between vector B and vector C, if the angles between vector B and vector C is 120 degrees, is 120 degrees, is 120 degrees, is 120 degrees, and the angle between vector D and vector A, vector D and vector A is 60 degrees, is 60 degrees, is 60 degrees, is 60 degrees. By using the scalar product, show that mod vector B square plus mod vector C square minus vector A square minus vector D square or modulus equal to vector A mod into vector D, vector A mod into vector D plus vector B into vector C. See, and the super part, this best question, nice question for this third part, right? It's continuous big problem. First I asked this adding of all 4 vectors equal to 0. Second, that idea of this product of 2 vectors by using right angle. Now this part they say additionally between B and C 120 degrees between the 2 vectors. So actually if you show in the diagram form, vector B and vector C 120 becomes somewhere here. This is 120 because the C approaching this point. B also approach, therefore outside. No, you can't take this 120. The angle is this case outside. So here the same A goes that side. So therefore this here, this is 60, right? This is 60. Here this is 120. So as we take that knowledge, if we know 2 vectors and the angle between them, their product, we can use mod A, mod B cos theta, that pattern. So we come to that part now. So given that B and C angle 120 degrees inclined, therefore you can write that third part answer. B dot C, vector B dot vector C is mod of vector B, mod of vector C cos 120. So you know cos 120 minus half second quadrant, therefore minus half into mod B mod C. This is B dot C here, right? Also similar, right, that given A and D are inclined at 60 degrees, therefore A dot D. So what is A dot D here? Mod A into mod D cos 60. Cos 60, so what? Cos 60 is half, now therefore half into vector A into vector D. Half into vector A into vector D. So see the first previous part question, mod A square, mod B square, that is okay. So here Same we have the a square, b square, c square, everything available. There's AD, mod D also available. So properly think how to work such a third part here. Answer is shown here. So how to collect it. So earlier problem I took from the result, first part problem, a plus b equal minus into c plus d. But here you need a and d together, b and c together. Therefore, from this result, I take a plus d equal to minus b plus c, and product itself, then simply can go to the answer. So therefore, from R I take a plus d equal what? Minus b plus c, So now product itself, so completely application of the scalar product. So product itself, therefore a plus d into a plus d into a plus d, the other side, minus become positive, vector b plus c into b plus c. Then you can multiple, also show this application, the result of this angle given, you can go to the answer. So we multiple a dot a, now you know the idea, a dot a means mod a cos naught, therefore mod a square, right? I say mod a square, yeah, a dot d, again a dot d, that becomes 2 times a dot d, 2 times a dot d, and what, d dot d, that's mod d square, right? Mod d square equal, follow same other side, multiple b dot b mod b square plus bc 2 times bc plus mod c square Okay, now we can apply the angle application. B and C inclined with 120 degrees. Therefore, B dot C is that. A dot D is apply that. Mod A square plus what is tried 2A dot D. 2 multiple 2 here. Multiple 2 times A dot D, that is mod A mod D plus D square the other side, mod B square plus what is 2B dot C, here come here B dot C, multiple 2B dot C minus time, so here minus, right? Minus mod B mod C at last mod C square. Okay, this is that part answer. Okay, that's the answer. Check. Rearrange. So therefore, B square plus C square minus mod D square minus mod D square equal to other two. Nice question. Nice work of this vector equal to mod D plus B dot is mod B into mod C. Is that answer? So I said this is fourth part. We have another part here. So say fourth equation. So no hurry, any problem, pause the video and check it step by step. See my explanation and how I work this, and I said how to apply this dot product and simplifying itself. So last I said using the scalar product, show that is the show answer. Another part there right below, or next part. Hence show that mod of vector B into 2 vector B minus mod vector C minus vector C mod equal vector D, mod of vector D into 2 into vector D minus, so it's plus vector A, mod of, right? The last part. The problem can be solved from this last part is this. Hence, what do you mean hence? Using the previous answer, we have to get this back. So what do you mean? So here no squares, no squares. Squares are vanishes, no squares available. So therefore you try to remove the square parts. See this equation number 3, one of the answer earlier part. We have square. So try to remove the square. If you remove the A square, here A square, B square, here. So if you remove it, you can get the answer, you remove it. Or if I write, again I write that number 3. I write here number 3. Rearrange the number 3. Take that side on that side. Mod A square plus B square modulus minus mod C square minus mod D square equal to 0 or 0 vector. We have all the numbers, therefore 0. I said this again I said third. Again say the third equation. This one. So we try to remove the squares at the board, at this board. Mod A square, mod A square, mod B square, mod B square, C square, C square, D square, D square cancel. So easy you can get the answer. At the 3 and 4 and check at the third and the fourth equation. At the third and the fourth equation. At the third and the fourth equation. So here mod A square cancel. Okay, mod B square 2 times mod B square. 2 times mod B square. C square cancel. D square minus 2 times D square mod D square. The other side mod A mod D plus mod B mod C. Okay. Now see the answer. Take one side and take the common factors, take the common part. Yeah, take this part here and take the mod B out, mod B take out. So here 2 times mod B, 2 times mod B minus C. Nice work. Nice part of this involving every previous sections. And just take that side and take the D out, mod D take out. So A, or we can say is 2, see the answer, 2 vector D plus vector A. So very useful question. The ideas are important to use any future exam style problem. So practice this my method of explanation. Very clearly you can answer such a problem in the future. So please subscribe this video and click the bell symbol, then you can leave a lot of comment. Automatically my videos reach you through the YouTube channel. The next video I'll show some more attractive problems in this vectors relation.